polygons today. So let's start with this. What are the things that we are going to learn? As usual, what polygons are, what properties are of the polygons, and then the different varieties of polygons, which is quadrilaterals part 1 and quadrilaterals part 2. Start with this. So obviously a polygon is defined as any closed figure having the straight line sides, any closed figure having the straight line sides. Then these are the different types of polygon: 3 sides triangle, 5 sides pentagon, a star shaped, etc, etc. These polygons can be classified into two types. One is convex polygon, one is concave polygon. So what are convex polygon? Two properties you should remember. One property is that the interior angles or the internal angles are all less than 180 degree. You can verify that via figure. And the second property is, if you try to join any of the two vertices, then that line which joins the any of the two vertices, it is gonna lie inside the figure. So line joining the vertices does not lie outside the figure. You can try it for any of the two vertices, and then you'll see that it is the true property. So these two are the classification or the identification of convex polygons. These are the different types of convex polygons. As usual, the second type is concave polygon, obviously exactly ulta. At least one interior angles, one of the internal angles is greater than 180, and line joining the two vertices is gonna lie outside the figure. Line joining the two vertices will lie outside the polygon. So these are the types of concave polygon. Now obviously, depending on the sides, these are the names. All these are Greek names. Nobody will ask you, obviously. Some properties you should know. So 3-sided triangle, 4-sided quadrilateral, the generic name. 5-sided pentagon, 6-sided hexagon, 7-sided septagon or heptagon, 8-sided octagon, 9-sided nonagon, 10-sided decagon. Then there is something called as regular polygon. So regular polygon is something which will have equal sides as well as equal angles. So all these are regular polygons. This is not the regular polygon. The sides are equal but the angles are not equal. So if we just slightly change that last figure, modify that last figure to something like this, and now you will say that it's a regular polygon because all the sides as well as the angles are equal. Now the properties of regular polygon. The first one, sum of all interior angles of a polygon is given by a formula n minus 2 into 180 degree, where n is the number of sides. Very important. So here it's a pentagon, n becomes 5, 5 minus 2, that is 3, 3 into 180, that is 540 degree is the sum of all interior angles of a pentagon. So n minus 2 into 180 degree is what we are looking at. The next one, basically the sum of an interior and exterior angle is always 180. That is, they are supplementary. You can clearly see, if you keep on drawing the exterior angles, the sum of interior as well as exterior is going to be supplementary. That is, the sum is 180 degree. The third property, sum of all exterior angles 360 degree. Then sum of each exterior angle is basically 360 by n. Again, n is the number of sides. So for pentagon, n is 5, so 360 upon 5, that is 72 degree is each of the exterior angle of a pentagon. Then there is each interior angle. Now we know the sum of interior as well as exterior, which is 180, and we just now have seen each exterior angle. So if we subtract each exterior from the sum of the interior and exterior, the result will be the sum of the measurement of each of the interior angle, and hence the formula is 180 minus 360 upon n. Again, the practical way to remember this, don't by heart. Remember, because you would know each interior, you would know each you would know sum, you would know each exterior. Subtract that from the sum, you get each interior. That is how you should remember. The next one, regular polygons, we are continuing the properties. Perimeter is n into length of each side. There is a pentagon, each side is x, so 5 sides, so perimeter is 5x. Then there is area. Now for area of the polygon, there is a very unique process which we are going to use, and which will also enable us to have a standard formula as well. So what we do is we join the center point with all the vertices, something like that, as you can see in the figure. And in turn, what we have done is we have formed 5 triangles here. So basically you find area of each of the triangles and do into 5, and you will have your answer. So area of each triangle, the basic formula, half into base into height. Suppose we consider the base triangle which is highlighted. Base is there x, let's draw the height which is h. So the area of that triangle becomes half into x into h, and there are such 5 triangles. Obviously here for pentagon, for hexagon it will be 6, for quadrilateral it will be 4, and so on. But the point here is you already know that n into x is perimeter, half of that is semi-perimeter, and hence the formula of area of any regular polygon is semi-perimeter into height, semi-perimeter into h. So we have derived this formula. Remember this, very important, very critical formula. And using here we will have the area of pentagon 5x by 2 into h. Again the h is defined as the height of a regular polygon, which is distance of the center of the polygon from any of the sides. So basically you can draw that perpendicular anywhere on the other bases as well, other 4 bases as well, and it will turn out to be the same. Now we can apply this formula to a regular hexagon, and the beauty of hexagon is when you join the center point with all the vertices, the triangles that you form are equilateral triangles. So this only happens in the case of hexagon, nowhere else it happens. Remember that as well, that the triangles are equilateral triangles, and straight away you have 6 equilateral triangles. So you can do area of equilateral triangle. You should know the formula, which is root 3 by 4 into side square. Such 6 equilateral triangles into 6, you will have your answer. But if we use the formula that we have just now seen, which is semi-perimeter into height, you are gonna get the same answer. So semi-perimeter will be 3x, and height will be root 3 by 2 into side, because it is a equilateral triangle. So in short, you get the formula as 3 root 3 by 2 into side square. So this is the direct formula of area of hexagon, again which you can remember it, 3 root 3 by 2 into side square, or you can derive this way by using semi-perimeter into h, or you can do it equilateral triangle ka area into 6 equilateral triangle, whichever way you remember, whichever way you look at it. Remember all the ways. As I said, you never know which one will be handy at which scenario. So this is how we apply the formula. The next part is the classification of quadrilaterals, but before that we would learn what are quadrilaterals and what are generic properties associated with them. So again, the first one, sum of all interior angles, we know it is 360 for quadrilateral, but because it's a polygon, we know the formula n minus 2 into 180 degree, and for quadrilateral 4 sides are there, so n becomes 4. So that gives us the same answer, which is 360. Now this is the proof that y p plus q plus r plus s is 360. This is the reason. Perimeter, sum of all sides, no problems with that. Area is a very unique thing. Two ways we can define this. One way is you join one of the diagonals like this. In turn, you have formed 2 triangles. Find the area of both the triangles, add them, you will get your answer. So area of triangle, half into base. Let's draw the 2 heights, h1 and h2. So top triangle, the area is half into h1 into d. The bottom triangle area is half into h2 into d. Half and d common, you get h1 plus h2. That's the area of quadrilateral. The second way can be you join the other diagonal as well. So d1 and d2 are the 2 diagonals, and the formula is half into d1 d2 sine theta. Remember this formula. This is going to have a connection and a reference point in the future, and this is the formula. Now the beauty is, again, it doesn't matter which theta you choose, which of the 4 angles you choose, because if this is theta, obviously the one beside that is 180 minus theta because of the straight line, and you know sine of 180 minus theta is still sine theta only. So whichever one of the 4 angles you choose, irrelevant based on the trigonometry that we have learned in the previous class. So this is the way you can find the area of the quadrilateral. Now, as I said earlier, the classification of quadrilateral in three ways this can be done. One is when both pair of opposite sides are parallel and equal, you get a parallelogram. When only one pair of opposite sides is parallel, you get a trapezium. And no pair of opposite sides is parallel, you get a kite or a generic quadrilateral. Because we want to study the properties of kite, so we will focus more on kite. So these are the three classifications. So let's start with each one of them. The first one is parallelogram. Now parallelogram itself is classified into three different categories. One is when all the sides are equal, you get rhombus. The second one, when all the angles are equal, you get a rectangle. And then there is a mixture of both of them, when the angles as well as the sides all are equal, and you get a square. So in these three ways, parallelogram itself is classified. So what we are going to do now is, hold your horses. We are going to study the properties, the individual properties of rhombus, rectangle, square individually, which is a classification of parallelogram, and then we'll also have to see for the other two classification of quadrilateral, which is trapezium as well as kite. So parallelogram is one classification of quadrilateral. That's the hierarchy that you need to follow. But before we go to the individual properties of rhombus, rectangle, square, let's study the generic properties of parallelogram, which is by default in a way will be applicable to all three of them. So the first one is obviously the opposite sides and the opposite angles, they are equal and parallel. That goes without saying. That's the name, that's the classification, and hence it is there. The next property is that the interior adjacent angles are supplementary. Look at the wordings: interior अंदर के side में, adjacent बाजू बाजू में, angles are supplementary. Supplementary sum is 180 degree. That is what we are looking at. Then the next one, the diagonals will bisect each other, will divide each other into two equal parts of the parallelogram. Then the properties of parallelogram, area is base into height. If somebody considers this as the base and this as the height, formula is BH. But for all you know, somebody can take the other side as the base and then the height will be different. So either you remember A into X or B into H, but remember the generic one, which is base into height. That is going to count more. Then there is one more formula of parallelogram ka area, which is AB into sine theta. Again, theta is the angle enclosed between the two sides. No other angle is required, only the angle between the two sides. Again, remember this formula. It is going to have a future reference in a while just now. So half into d1 d2 sine theta from quadrilateral and AB sine theta from parallelogram. Okay, let's start with the classification of parallelogram. The first one, where all the sides are equal, you get a rhombus, and the properties of rhombus are as following. The first one, the diagonals of a rhombus are the angle bisectors of the vertex angle. So they divide the vertex angle into two equal angles. The second one, the diagonals of the rhombus are perpendicular to each other, so they intersect at 90 degree. The next one is obviously perimeter and area, but before that, the diagonals of a rhombus also divide the rhombus into four congruent triangles. So these four triangles which have been highlighted right now in the diagram, they will be congruent triangles. Their angles, their sides, they all are equal. Then perimeter, sum of all sides, that goes without saying. Each side is x, perimeter is 4x. Area, so parallelogram ka subtype is rhombus. So area of parallelogram, which is AB sine theta, the general formula is applicable here. It will give you x square sine 2x or x square sine 2o. But you remember that parallelogram itself is a classification of quadrilateral. So area of quadrilateral ka formula should hold true as well, which is half into d1 d2 sine theta. So half into d1 d2, but sine theta, the angle is 90 degree, and you know by now using trigonometry that sine 90 is 1, and hence that term of sine 90 goes off, and the formula is half into d1 d2. These are the reasons, and this is why this is the formula. You should remember like this again, because You should not just by heart, you will not remember it for a longer duration. You should remember it with a connection, that why it is like this. The second classification of parallelogram, when all the angles are equal, we get a rectangle. The properties of rectangle, the diagonals are equal, but they are not perpendicular to each other. And the four triangles that we get because of the diagonals of the rhombus, because of the diagonals of the rectangle, they are equal areas. They will have equal areas. These four triangles will have equal area. Perimeter, as usual, 2 times length plus breadth. Area, parallelogram, so AB sine theta, that is LB sine 90, which is 1, and hence the area of rectangle is length into breadth. This is the proof. We have been doing this in school days. Area of rectangle is length into breadth. Why it is like that, we come to know now today. The other one, from the quadrilateral, which is half into d1 d2 sine theta, half into d1 d2 are equal, and sine theta as it is. So d1 d2 equal becomes d square. So half into d square sine theta is the another formula for area of rectangle. Now the third and the last classification of parallelogram, which is angles and sides both are equal, you get square. And because square is the combination of rhombus and rectangle, so both their properties will hold true. So all you have to do is copy paste both of their properties here. The first one, the diagonals are equal, angle bisector, perpendicular. Equal has come from rectangle, angle bisectors and perpendicular came from rhombus. Then the triangles, because of the diagonals, the four triangles, they will be congruent triangles. Perimeter, sum of all sides, each side is x, perimeter is 4x. Area, it's a parallelogram ka type, so AB sine theta, which is x square, sine 90, which is 1, and hence it is x square, which is side square. You would know now why it is. And then lastly, quadrilateral ka area, half into d1 d2 sine theta. d1 d2 are same, that means it is half into d square. Sine 90 is 1, that term goes off. So half into d square is the other area. One additional relation you should remember as far as square is concerned, that the diagonal of the square is actually root 2 times the side. There is a correction, mind you, it is root 2 times the side, not root 3 times the side. There is root 2 times the side. Remember that, do that correction here, not root 3, but it is root 2 times the side. So that these are the three classifications of parallelogram, which was itself one classification of quadrilateral. Second classification of quadrilateral is trapezium, where we have just one pair of opposite sides parallel. The other set of side which is not parallel are also called as oblique sides. There's a technical name to that. So let's study the properties of rhombus in detail now. The first one, the properties of trapezium. The first one, if the oblique sides of trapezium are equal, then it is called as an isosceles trapezium. Then the diagonals of the trapezium cut each other in the ratio of the parallel sides. So suppose the ratio of the parallel sides is S1 upon S2. So diagonals themselves will also cut in that same ratio, which apparently is, suppose A upon B is equal to X upon Y is equal to S1 upon S2. The third one, the two triangles that are formed by the oblique sides and the diagonals, that is the two sideways triangles, they are gonna have equal areas. The one which are being shaded right now, these two triangles will have equal area. Remember these all properties. Then the midpoint of the oblique sides is called as the median of the trapezium, and when we join that line, the best part is it is parallel to both the parallel sides, that is S1 and S2, and it is also average of both the parallel sides, that is median is given by S1 plus S2 upon 2. And lastly, as usual, perimeter and area. Perimeter, sum of parallel sides as well as sum of oblique sides. Area is uniquely, you draw the height h, and again on the other side also you draw the height h, and then you have converted your figure into two right angle triangles and one rectangle, and you add all three of them, and this is what you get after all this simplification, which is half into S1 plus S2 into H. Obviously, half into S1 plus S2 we have just now seen in the previous slide that it is called as median. So area of trapezium is also given by the formula median into height of the trapezium. Again, you should remember everything because based on what kind of information you are dealing with, you would be required to use one of them. So this was the second classification of quadrilateral, which is trapezium. One pair of opposite side is parallel. The third and the last one, no pair of opposite side is parallel. You get a kite or a generic quadrilateral. Obviously, kite, any random quadrilateral cannot be kite. There has to be some criteria also that the adjacent sides has to be equal. So the right one is not the one. The left one is the kite. Why? Because each pair of adjacent sides are equal. Let's start with this. The properties of kite. The first one, the diagonals are perpendicular to each other. They will intersect at 90 degree. Then one of the diagonals will bisect the other diagonal, but it will also bisect the corresponding vertex angle. So suppose the vertical diagonal, it will not only divide the horizontal diagonal into two equal parts, but it will also divide the corresponding vertex angle. That is the properties of the kite's diagonal. Then as usual, perimeter, two adjacent sides, which is two pair of adjacent sides, which is a plus a2a and b plus b 2b, that is 2 times a plus b. And lastly, area. Now trapezium, sorry, the kite is not a type of parallelogram, so AB sin theta will not be there, but it is a classification of quadrilateral. So quadrilateral ka area ka formula, which is half into d1 d2 sin theta, will hold true here, but obviously sin 90 is 1, so that term goes off and we are left with half into d1 d2. So these are all the properties of kite, and with this we are. So the first question, this is the first question. The height of a regular octagon is 20 centimeter. Find its area. Now clearly octagon is also a polygon, and for the area of polygon we have discovered a formula in the concept, that is semi-perimeter into height. But this is the question where you will absolutely require to know how the octagon is formed. If you don't know that process, you won't be able to find out the answer for the question. So this is a octagon will look like with the 8 sides. Regular octagon, so all sides should be equal. Then when we join the center point with the vertices, we end up forming the triangles. We need to find area of each triangle into 8 such triangles and we'll get the area of the octagon. So the basic process was, formula was semi-perimeter into height, and the height is known to us, which is 20. Perimeter will be 8x, semi-perimeter will be half of that, which will be 4x. So formula becomes 4x into 20, which is 80x. Now, the only thing we should know is the side of the octagon. If we have that value of x, we can just substitute in this and we'll get the answer. But to do that, as I said earlier, we'll have to know how the octagon is formed. So how the octagon is formed? So the octagon is formed by cutting the corners of the square at 45 degree. How it is formed? By cutting the corners of the square at 45 degree. Remember this process. Now, what you then end up realizing is all these small triangles at the corners, when we cut them, they are your 45, 45, 90 degree triangle. So let's consider one of them, slightly extend that with the hypotenuse as x, and it's a 45, 45, 90 degree triangle. So we know the properties of 45, 45, 90 degree triangle, that side opposite to 45 degree is 1 upon root 2 times of hypotenuse. So both these sides will be x upon root 2. Then we can extend that height 20 on the other side as well, something like this. And now what we can actually do is solve a simple equation. The entire length of the height of the octagon is 40, 20 plus 20, which is a sum of x by root 2 plus x by root 2 plus x. And this is the equation that you will have to solve. Solving this equation, you will get the value of x, substitute that value in the original formula 80x, and you will have your answer. So when you solve this, you get the x as 40 times 2 root minus 1 after a lot of solving and rationalization and basic calculation. Substitute that value of x. When you multiply that with 80, you get 3200 times root 2 minus 1 centimeter square as the area of the regular octagon, which is option 3 for the first question. Second question, which quadrilateral is formed if we join the midpoints of the sides of the any general quadrilateral? So general quadrilateral, if we join the midpoints of the sides, this is what the figure looks like. And clearly, intuitively, you will say that it's a parallelogram and you all are correct as well. But let's try to understand the proof that how it is a parallelogram. So for that, what we can do is join the horizontal diagonal of the regular general quadrilateral. When you do that, what you realize is you have converted the quadrilateral into two triangles, and in the upper triangle and in the lower triangle we can use something called as midpoint theorem that we have discovered in the previous session of G2, that is triangle properties. So when you apply that midpoint theorem, what was the midpoint theorem? Line joining the midpoints of the other two sides is parallel to the third side, and it is also half of the third side. So these two lines, the line that are joining the midpoints, they will be parallel to the base and they will be also is equal to half of the base. Yani both these lines are also parallel to each other then, and they are equal as well. Same thing you can do by joining the vertical diagonal, and you can again use the midpoint theorem for these two triangles and you can get the same conclusion. So this pair of opposite side is also parallel and equal. So both pair of opposite sides are parallel and equal. So obviously the figure that we get is a parallelogram. So answer is parallelogram, option 5 for the second one. Now what we have done is actually we have compiled a list that, for example, you can refer that directly, that going forward, if at all you come across such things that this is a standard figure, and if you join the midpoints of the sides, what will be the resultant figure that you will end up forming? So you can just remember that list as a go-to way of doing this. So basic shape, if it is a rhombus, if you join the midpoints of the sides, you will get a rectangle. If it is a rectangle, you will get a rhombus. If it is a square, you will get a square. If it is a trapezium, you will get a parallelogram. And if it is a kite, you will get a rectangle. So these are some of the model answers that you can directly remember. Third question, an equilateral triangle, a square, a regular pentagon, a regular hexagon, and a regular octagon have the same perimeters. Which figure will enclose the maximum area? So two criteria that are very, very important. If you read properly the question, they are mentioning very precisely that all the figures are regular. That's a one criteria. And the second condition is they all have the same perimeter. So if at all this is going to be the case that the figures are regular and they have the same perimeter, so the simple logic that you will have to remember is the figure with the maximum number of sides will enclose the maximum area. For example, the figure with the maximum number of sides is clearly the octagon, and hence the regular octagon will have the highest area, which is option 3. So this is that rule which you can remember. In case of regular figures having the same perimeter, area enclosed increases as the number of sides increases. Regular figure, same perimeter. These are the two criteria. Fourth one, a rectangular garden has a length of 30 meters and a width of 20 meters. A pathway of width 2 meter is to be made along the sides of this garden. What would be the area and the perimeter of this pathway if the pathway is across the middle of the garden? So this is how the pathway is in between exactly middle of the garden. Width is 2 meters. We have to find the area and the perimeter. So if you want to find out the area of the pathway, it is actually this area of rectangle that we are looking at. So horizontal rectangle, the smaller one with the dimensions 30 into 2, and the vertical one with the dimensions 20 into 2. But I hope you understand, when you do that, the in between portion, the small portion is counted double, and that is the one that we need to subtract, the shaded region. So that region will have to subtract a small block of 2 by 2, and after doing all of this calculation, you get the area of the pathway as 96 meters square. Similarly, we want to find out the perimeter of this pathway. Perimeter of this pathway and a boundary of this pathway, which is this line that is being highlighted right now. But if you have really good observation skills, what you can actually understand is that when you do a little bit of restructuring, you'll realize the perimeter of the pathway is actually exactly coinciding with the perimeter of the rectangle itself with these kinds of shifting. So ideally, we are looking at perimeter of rectangle, which is equal to perimeter of the pathway. So this was the smart thing that you could have thought of. So perimeter of rectangle, we know the formula, 2 times L plus B, 2 into 30 plus 20. Again, you get the answer as 100 meter as your perimeter. So 96 meter square is the area, 100 meter is the perimeter. Fifth one, find the area of the shaded region if each side of the outer hexagon is 10 centimeter long and the vertices of the inner hexagon lie on the midpoints of the outer hexagon. So shaded region is actually this one. So for the area, what we need to do is area of the outer hexagon minus area of the inner hexagon is the formula that you will have to remember. And this is where, if you are using the direct formula of area of hexagon, you will definitely not get the answer, because you need to know the process of actually calculating the area of the polygon. So if you remember the fundamentals, that for finding out the area of any polygon, what was the process? That we used to join the center point with all the vertices and we used to form the triangles. And because it's a hexagon, the triangles are the specific triangles that are equilateral triangles. So suppose for the outer hexagon, the red one, we are joining and we are getting the red equilateral triangle. So for this area, we know the formula for area of a triangle, that is root 3 by 4 into side square, and there are such 6 equilateral triangles. So you will get the answer for the hexagon ka area, which is on the outer side. Now, for the inner side, we'll repeat the same process. We'll join the center point with the vertices and again we'll form the 6 equilateral triangles. But hold on, what we can do actually is, let's try to find the height of this red equilateral triangle, which is the outer hexagon representation. And obviously, because it's an equilateral triangle, let's draw the height, which is the perpendicular dropped from the center to the base. Now, that height is actually the height of the equilateral triangle. And because it's an equilateral triangle, we can find the height directly using the relation root 3 by 2 into side, which gives you 5 root 3 as the answer. So the height of the equilateral triangle is 5 root 3. Now for the area part of the blue hexagon, the inner hexagon, when we repeat the same process of joining the center point with the vertices and forming the equilateral triangles, what you end up realizing is that the side of the inner hexagon is actually the height of the outer hexagon. And this is the point that you had to understand, which was the break even point where you will get the answer. So height of the outer hexagon is the side of the inner hexagon. We have already calculated that, which is 5 root 3. Again, you have 6 equilateral triangles. Area of equilateral triangle, root 3 by 4 into side square. 6 such equilateral triangles will get your answer. So 6 root 3 by 4, that is 3 root 3 by 2 is common outside. You are doing the calculation of 10 square minus 5 root 3 the whole square, which is 75 root 3 upon 2. So this is the area of the shaded region, is what we are getting as the option. Now, the sixth one. Mitul draws the square with the side 8 centimeter. He now takes the midpoints of all the four sides and draws another square, joining all the four midpoints. He repeats the process 6 more times and in the end realizes that he has 8 squares in all. He calculates the area of the innermost square. What is the area? So let's repeat the process what he is doing. Original square with the side 8 centimeter. Let's join the midpoints and we'll get another square. So original square with the side 8 centimeter, the area is 64. The new square, the side will not be 4, huh? The side will be 4 root 2. So the area will be 4 root 2 ka square, which is 32. So if you observe the pattern, what has actually happened is when you do the process of joining the midpoints and then finding the new square and the area of that compared to the old square, the area is half of that. And clearly, if you remember, he has total now 8 squares in all. So all we have to do is keep on continuing the same pattern. So for the third square, the area will be 32 ka half, which is 16. For the fourth one, it will be 16 ka half, which is 8. For the fifth one, it will be 4. For the sixth one, it will be half of that, which is 2. And for the seventh one, it will be half of 2, which is 1. And for the eighth one, don't stop till you get the correct answer. There were total 8 squares if you remember. So for the eighth one, the area will be half of that. So 1 ka half is half and the answer is half. So the eighth one, the smallest innermost square, the area answer is half square centimeter, which is option 3 of the sixth question. Seventh one, a square and a rhombus share the same base. However, the rhombus is inclined by 45 degree. Sorry, there was some internet issue. So the sixth one, if you have not understood that, we just have to keep on doing. When you find the area of the square of the first, when you find the area of the first square and the area of the second square, the answer is half of the previous value. So on you repeat the process for the 8 squares for the innermost square and you get the answer as half for the 8th square. Just keep on doing half of the previous value and you will have your answer. Seventh one, a square and a rhombus share the same base. However, the rhombus is inclined by 45 degree. What is the ratio of area of rhombus to the area of square? Area of rhombus to the area of square. So rhombus and square are sharing the same base. Rhombus is inclined by 45 degree. Formula for square, side square, which is a square. Formula for area of rhombus. Rhombus is a parallelogram. So AB sine theta is the formula which gives you a square sine 45. Now sine 45 is 1 by root 2. Now the thing is, in this particular PPT, they have done the reverse of what is supposed to be solved actually. So their ratio will be opposite. You will have to read the question properly. We want to figure out the area of rhombus to the area of square. So ratio of area of rhombus to the area of square. They have done ulta, square to rhombus is what they have done. So rhombus will be in the numerator and square will be in the denominator originally. They have done ulta. So the answer that they have got, root 2 is to 1, is not correct. It should be 1 is to root 2. The answer should be 1 is to root 2, which will be a different option. So whichever that option is, mark that. 1 is to root 2 is the correct answer. Because this upon this is what we are supposed to calculate. So sine 45 will be 1 by root 2 upon a square gets cancelled, which is 1. So actual answer is 1 upon root 2 is to 1. When you simplify that, you will get 1 is to root 2. So that is the answer. If the question would have been area of square to rhombus, then root 2 is to 1 is the correct answer. But the question is ratio of area of rhombus to the square. So answer is different. Pay attention to all these small things when you are doing the calculation. Eighth one, find the area of the shaded portion where ABCD is the square. Now this is where things are very, very important that you need to recollect what we have covered in the previous sessions. And this is what the first thing about geometry, that everything is there right front of you in the diagram, in front of your eyes, is just that we are not able to identify. So if you just flip that shaded region wala figure, you'll realize that we have done something called as property of triangle sharing the same base in G2. And there was a relationship that we had to remember directly. 1 upon x is equal to 1 upon y plus 1 upon z. So first of all, PO and BC, they are parallel. I hope you understand that. So from point O, we'll have to drop a perpendicular on BP, which will be your x, which will also be parallel to PQ and BC, something like this. And now once you have this, we can use the relationship to find out the value of x. That is 1 upon x is 1 upon y plus 1 upon z. Property of triangle sharing the same base. X, y, z are parallel to each other. You solve this equation, you'll get the value of x, which is 20 by 7. When you have this answer, now why did we bothered finding out this value of x is because we are supposed to find out this shaded region. And this shaded region is actually area of triangle CPB minus area of triangle OPB. Area of triangle CPB minus area of triangle OPB. So CPB का एरिया तो आ जाएगा हाफ इंटू बेस इंटू हाइट. OPB के एरिया के लिए भी हाफ इंटू बेस इंटू हाइट यूज करना है. OPB का बेस सेम है PB, बट उसका हाइट x नहीं था, इसीलिए ये कर दिया. So that is the connection. So area of shaded region is area of triangle CPB. This area, the one that is highlighted, half into base into height. Base is 6, height is 10, minus this area, OPB, half into base into height. And the height of OPB is x that we have found out. Do the simple calculation. You get your answer as 150 by 7, which is option 3 for the 8th question. So something that we have done already is being used here, and this was that diagram, property of triangle sharing the same base, if you remember this. And the same figure is here, but in the inverted manner. So these are things you'll have to remember. So folks, that's it for today from Polygons. Go through this again if you have any questions in any of the specific ones. If you still don't understand anything, do let us know. We'll be happy to help you. Thank you so much.